Might?
Yeah, I don't know why they don't. By the way, quick little side note, if you guys never watched any of the videos, I wouldn't care because they help me. I'll say, did I say there was a quiz? No. They're being watched. This is great. And somebody was like, why don't you monetize them? I'm like, are you kidding me? I don't really want to sit through like a 6 second, I'm like, 6 second unskippable, screw that shit. So I'm like, I just want my students to watch the damn things. I don't want to put ads, watch an ad.
Plus, if you monetized it, anytime you cursed or one of us cursed,
Oh, true. Yeah.
you wouldn't get it.
Well, it's in the first whatever seconds. I don't care. I'm not a YouTube creator, dear God. I just happen to put my shit on YouTube. So, all a decimal is, it's a fraction that fits in our number system. Do you guys see what I mean? Guys, you guys understand what I mean? So any fraction, because every single decimal is some kind of over 10, 100,000, some multiple of 10 on the bottom, correct? So that's all they are fractions that happen to fit into our number system, that's it. So just to push my luck for a second, this is not a big deal. It's only going to show up on a bonus maybe. But if I had base 5, what would this be? This is the ones place. What place would this be?
That would be the 5?
Fifth place.
The 25th.
25th. 125th. That's all. That's all it is, right? So that's how every place works. I multiply by the base to build up, and I divide by the base to build down. You with me? That's how any base system works. We just happen to have base 10. Okay. So again, we're not going to do different base decimals. I would make a bonus problem maybe, like I did before, just a little bit worse. Y'all with me? I just want to point that out. Whatever the base is, you just divide by it to figure out what all the places are. Just like you multiply by it to figure out what the places are going the other way. Exactly the same thing. Okay. Now something really, really cool. Does anyone happen to know what 1/3 is as a decimal?
0.33333. Repeating?
Keep going. No,
3333333333333. 1.
No, it's just always 3. Yeah. So is everybody cool with that bar up there? Y'all know the bar means what? Keep going. Right? It just means keep going like that. Y'all with me? So, do you agree this is non-terminating? It cannot self-terminate. It's non-terminating. So what's an example of a terminating decimal? Would be one that stops. All right? Now what's interesting is, so real quick, give me a decimal that stops. Give me a couple numbers.
25.
25, okay. What is that as a fraction?
1/4.
Sure, 25 over 100, which reduces to 1/4, and of course we all know what 1/4 is, 11. Y'all with me? So any terminating decimal, I can write as a fraction easily. Y'all with me? If it stops, and I don't care if it stops really far out, I can just count, and then I can put that many zeros after the 1 on the bottom. Is that you could make so? Can you take a second? We just did one like this, but just to really hammer the point home. You can make a number there. There you go, John. What would that be as a fraction? Don't say anything. Write it as a fraction. So it's easy as shit, right? It's all about the number that goes in the bottom, and I just gave you a nice way to figure that out. Yeah, so you get 4, 8. So you have 8 zeros. Which is? 100 millions. I like it. 100 millionths. Gotta have that lift going on. Okay. Is everybody cool? I haven't done anything too crazy yet. But does everybody understand? I don't care where it ends. If it stops, I can make it a fraction. Hell yeah. Because I can just count. So I can have 80 zillion zeros. You know, it's not really a number, but still. I got 80 billion to the billionth power zeros. It's still a fraction, you know, I can still do it. But does this terminate? but I can still write it as a fraction. Isn't that weird? So only certain fractions will end up becoming terminating decimals. Let me say that again. Only certain fractions will become terminating decimals. I think I write like I'm drunk. It's bad.
Should be a doctor.
Huh?
Should be a doctor.
I mean,
Yeah, I know.
technically he is a doctor.
Not really.
Oh, he's a
Oh,
doctor?
here
No.
notes you can sign off on.
Two masters don't become a PhD, unfortunately. So I'm not a doctor. I'm just Jeff. All right. So what has to be true for it to become a terminating decimal? Can somebody give me the simplest fraction that I can write immediately as a decimal?
1.25.
Okay, cool. I like it. That's good. That's good. What is that? 0.25. But really tell me, do y'all know why that's 0.25? Not just because 4 goes into 1.25, blah, blah, blah. Because I can make that out of what? 100. So if I multiply by 25, multiply by 25. So I want you to realize something. Even though we're stepping into decimals, there's going to be a lot of fractions in this section because decimals are just fractions. So we're still going to see fractions. So I'm sorry if you were excited that we're about to leave the fraction section. We never leave it. It's always with us. And on the paper. Do you see how I could make 4 become 100? And it was easy. I didn't have to multiply some weird number. What is 4 made of? Break it down. 4 is
2.
2 times 2. If I give each of those 2's a 5, doesn't that make 10 times 10?
Yeah.
Okay. I'm trying to see if you guys can actually come to this. So if I had a 1/7, can I ever make that some 100,000? Can I ever make that?
No.
Definitely not, because any multiple of 10 is only going to have what factors in it? No, well, no. Any multiple of 10 will only have what factors in it? 2 and 5. Ignoring 1 and true factors, right? You guys kind of with me? So if I start with a fraction that has a number that's not a 2 or a 5 in it, it's never going to become a terminating decimal. Who's got a calculator? What's 1 divided by 7? It's 0.14 or something.
Wait, 142857142.
I knew it was 2. So
But this one doesn't show us repeating, so how would we go about that?
wait, what do you mean?
Like it just kind of stops at the end of the grid.
Totally, because the screen doesn't like flip out. So at some point the calculator goes, it just has to stop somewhere, correct?
Yeah.
But does it have a pattern that you can see?
You're right.
But you're also right. That's not proof. Maybe immediately it repeats all the shit it just said off the screen. That could be true, but does it make sense to be a terminating? I need you guys to be a terminating decimal. That means it immediately can be written with a multiple of 10 on the bottom. Is everybody cool with what I just said? If I give you a decimal that stops somewhere, on the bottom you can put 1 followed by a bunch of zeros. Somebody, here, real quick, let's do this. All right, prime factor 100 for me. This is like an upset person, but it's okay. Prime factor 100 for me. 2 times 15. 2 times 25. 5 times 5. So what's you got in it?
2 5s and 2 2s.
2's and 5s. 2's and 5s. Prime factor 1,000. Let's do it a different way. 5 times 200, let's say. All right.
2s and 5s.
Is that all right? 2 times 100, and 100 we already did. 2's and 5s, 2's and 5s, everybody. So if your decimal starts off with a number other than 2 and 5 on the bottom, that poor little dude ain't got a chance. It's never going to become a terminating decimal. You guys kind of with me? So repeating, it could be repeating, but that still means not terminating. So 1/3, does it terminate?
Yeah. No.
Does it terminate? No. Why is that not surprising? Because it's got a number that's not a 2 or a 5 on the bottom. Yes.
Okay, but I have a question.
Sure.
Might be getting a little too high level, but if you multiply that number by 3, it gets back to 1. I never quite understood how that happened if it's always all 3s.
I learned this in high school. Think of a number between 0.9 repeating and 1.
Yeah.
So very quickly, we do a couple things related to that. You ready?
Yeah.
Yeah, because the whole idea here is if I multiply both sides by 3, and this to me is one of the funniest little things that a lot of people kind of argue about. You're gonna get, on this side, you're gonna get 1, but what do you get on this side? Right, because you're 3 times 0.333 is 0.99999, right? Now listen, here's the neat thing. This is gonna be really strange. Go with me for a second. Why is 7 equals 7? Because 7 minus 7 is 0. So to show that two numbers are equal to each other, the difference between them needs to be 0, correct?
Yes.
That is 0.9, and it just never stops with the 9s. Are you with me?
Yeah.
All right. I'm not going to spend all day on this, but what's 1 minus 0.9?
0.1.
0.1, 11. 1 minus 0.09,
0.01.
I'm sorry, 0.99, yeah,
Yeah.
0.01. 1 minus 0.999. Do you see how this keeps getting pushed out?
Yes.
So 1 minus 0.9 forever is going to be 0.000 forever, which is basically 0.
Okay.
So since 1 minus 0.9 is 0.9 repeating is basically 0, 1 equals 0.9 repeating. Now, dear God, that's all I'm going to say, because that's a neat thing. It's a little bit above what we got to worry about, but it's neat. And if you ever see the 0.99 repeating thing somewhere, it shows up on social media every now and again. It's not that crazy, but it is kind of cool looking, because you're like 0.99 forever doesn't equal 1. Yes, it does. It really does. Why? Because if you think there's a distance, you can just go further. If you think you can just go further. If you think there's no, you can just go further. There is no distance between them. And I'm sorry, that's a bit much. Now, what I do want to talk about is this: the fact that I've run out of paper already. And, hold on, I got paper. Here we go.
Barely not where the actual.
Huh?
There's a 2 and a 5.
Yes, so real quick, okay, before I forget, let's just do a nice basic thing. This is what we're gonna have to worry about. What I'm about to do, we also have to worry about, but it's a neat thing. So can I find a terminating decimal representation for, it doesn't matter, this?
Yes.
Yes.
Why?
5.
Careful, what's 75?
It's 25 and 3.
25 times, oh shit, yes, isn't that an oh shit?
Yeah.
That's an oh shit. Oh shit, it's a oh shit. I'm looking up there trying to write, it's never a good idea. There we go. Oh shit, I can't spell oh shit. I need you to understand, if it asks you, can you represent this as a terminating decimal? You cannot, because it has a factor of 3 in it. It only can have factors of 2 and 5, correct? What about 3 over 125?
Yes, because it's 5.
Yeah, what's 125? It's 5 times 25.
The 25 is
So it's 5 times 5 times 5. Now somebody help me out. Help me, right? Don't I have 3 5s on the bottom?
Yes.
How many 2s do I have to multiply by so I get nothing but 10s? This 5 needs a 2, this 5 needs a 2, this 5 needs a 2. So don't I have to multiply by 2 times 2 times 2?
Yeah.
Wouldn't that make the bottom some multiple of 10?
Yes.
What is 2 times 2 times 2? 8. So if I multiply top and bottom by 8, I get 24 over 10 times 10 times 10 is 1,000. So that is 0.24. Somebody verify that in your calculator. What is 3 divided by 125? I'm sorry, 0.024. You can count, Jeff. Sometimes. I need you guys to be with me. See, if you break the bottom down, you see that it only has 2s and 5s. You can also then tell what does it need to become 10s. Are you at all with me? So if the bottom only has 2s and 5s, that means it's terminated. You could also determine then, well, how many 2s and 5s does it need to become 100, 1,000, whatever it is? Okay. Is everybody semi with that?
Will you
I
repeat?
get it.
If the bottom has a factor other than 2 and 5, it is impossible for it to be terminated. Why does that make sense? Every terminating decimal would have a multiple of 10 on the bottom. You agree? If we stop after the first place, it's 10. Second place, 100. Third place is 1,000. Yes? So the bottom is going to be some multiple of 10, and the only factors 10 has are 2 and 5. So if I have an extra factor of 3, like in that first one, there's no way I can take care of that. I can't make that become 1,000, 10,000. That 3 is going to be eternally in the way. Stupid 3. So, not sure how else to say this. 1/25. What do I multiply by to make it 100? 4, right? Is that cool? So 1/25 will be 4 hundredths, which is 0.04 tenths hundredths. Is that all right? Why does that make sense? Because 25 was 5 times 5. So of course each 5 needed a 2. You just never thought about that like that before. So if the bottom of the fraction has only 2's and 5's, it could become a terminating decimal. If it has more than just 2's and 5's, it cannot. So let's create one. 1 over 5 cubed times 2 squared. What is that? 1 over...
$500.
500, right? And 1 over 500, if you do that in the calculator or if you do it by hand, you're going to get 0.002. So if you create a fraction and it's only got 2's and 5's on the bottom, it will be terminating. Okay, I'm going to stop talking about that. That is part of the homework. They're going to talk about helping you tell if something's terminating or not. So just like the very first problem we did, if it's got any number that's not a 2 or a 5, it's got no chance. Poor little dude. Okay. Now one thing I want to talk about a little bit early.
Any number that has a 2 or 5 is.
If it only has 2's or 5's on the bottom, it will be a terminating decimal when you multiply, when you divide it up.
Okay.
So like, again, so in your calculator, you can do 13 divided by 40. What do you get?
325.
0.0325?
No.
Or 0.325? Okay, that makes more sense. Did that, so it terminated, yes?
Mhm.
Why does that make sense? Because what's 40?
2 and
2 times
20.
20. What's 20? 4 times 5 was 4, 2 times 2. So it's got 2, 2, 2, 5. It's only got 2's and 5's. So of course it terminated.
Okay.
Of course it did. Yes? Maybe.
Can you say that other rule again before you did the 13 over 40? What was it? It can only terminate if what?
If the bottom has 2's and 5's, it will be a terminating decimal if the bottom only has 2's and 5's in it. So why didn't this one work here? Because it had a 3 in it. If you divide 4 by 75, it's going to keep going. Your calculator is going to give up at some point. Okay. You're welcome. There's one little thing I want to do a little out of order because it came up. Let's see if you guys, what you guys think about this. I have a feeling not many of you have seen this before. I'm going to prove that 1/3. I'm sorry. I'm going to do the other one. I'm going to prove that 0.333 repeating is 1/3. I'm going to prove that. And this is actually part of what they do in the book. So this is part of what they're going to ask you about in the homework.
Just hang over a little bit.
Yeah, let me see if I can do this better. There. So I'm going to do another example after this. Anything that has any repetition to it, you can do what I'm about to do to see what it is as a fraction. Every repeating decimal can be represented with a fraction. Yes. Are there decimals that cannot be represented with fractions?
Yes.
Totally. Can somebody give me one of them?
Pi.
Pi. It's a beautiful example.
Pretty sure pi.
Square root of 2. Any square root I can't do is a beautiful example. Not surprisingly, those are called irrational functions because I cannot make a ratio of numbers out of them. So they're irrational, not ratios. Okay. Alright, so watch this. This is kind of cool. I'll do another example after this. So at first, before we knew what this was, we had no idea. So I'm going to call it x. Because that's what we do when we don't know what something is in mathematics. What sucks about that number, if I'm trying to make it into a decimal, it just never freaking stops, correct? If it would just stop, I can make a fraction out of it, right? So look what I'm going to do. Look what I'm going to do. If I multiply both sides by 10. Now this is kind of cool because it's also wrapping in this idea of decimals are based on the tens places. So when I multiply by 10, it should be easy. What happens when I multiply any decimal by 10? You guys know.
It will go up.
The decimal just moves 1 over. So I'm going to move this over 1, so it becomes 3.33, repeating forever, yes? What happens if I subtract both sides? 10x minus 1x is 9x. Is that cool? And what do I get here? Don't these parts cancel?
Oh, yeah.
The infinite 3's cancel, right? It's not a bad band name. We're the infinite 3's.
They got canceled though.
They did, but you know, that's what happens. You don't want to sell out. 3 plus 0?
3.
3 minus, I'm sorry, subtract. 3 minus 0. Do you guys see that? It's kind of cool. So that's a neat trick. What sucks about that number is it goes forever. So why don't I do something where I can cancel the part that goes forever? And how do I solve for x? Don't I just divide by 9?
9 squared. X
3 over 9 is 1/3. So we just proved that 1/3 is 0.333 forever. Now what's really neat is if 3/9 is 0.333 forever, what do you think 2/9 is? You can do it 222 forever. And what's 1/9? 0.111 forever. Okay, you guys kind of with me? So what's 9/9?
1.
You ready? 0.999 forever. So there's another way to prove that 0.999 forever is 1. Yes?
Is that an equal sign or are those Z's like a symbol?
Oh, here?
Yeah.
Oh, these are equal signs. They're lazy equal signs. So yeah. We'll do another example like this because this is in the book. This is not just me doing weird shit with you. And I understand you sometimes can't tell.
Wait, how did you get rid of the?
So if I multiply by 10, the decimal moves over 1,
Yeah.
and then I subtract. So these parts go away.
How did you get rid of the
10x minus x is 9x.
10? Oh, I used mid. I see.
Yeah, subtracted both sides. Yeah. So watch this. 0.131313 forever, yes? I claimed that any repeating decimal I could write as a fraction. So I should be able to write this as a fraction. So I'm going to do the same trick we did a minute ago. I'm going to call 0.1313 forever, I'm going to call it x. Now, here's the real trick. I'm not going to multiply by 10. Because if I multiply by 10, the repeating part doesn't line up. Do you guys see what I'm saying?
Yes.
Since the repeating part is every 2, I'm going to multiply by 100. If I multiply by 100, the decimal moves twice over, so now I got 13.131313. So if I had a repeating decimal where the pattern was every 4, I would have to multiply by 10,000. So then I moved the decimal far enough. Now did I match up so if I were to subtract both sides, doesn't this entire thing cancel with this entire thing?
Yes.
So I just left with 13 equals 99x? 13 over 99. So real quick, what do you think 15 divided by 99 would be?
1515.
0.151515. Try it. Do 15 divided by 99. What is it? 151515, yeah.
Ending with a 2.
Say again?
Ending with a random.
True, so what's your calculator doing at the end? It's rounding.
Okay.
It rounds, so yeah, it's trying to be honest. If it just chopped it, that's not being honest. Okay, sorry, I did this a little out of order, but yeah, sure. Let's see, let me get back to where I need to be. Yeah, okay. We're gonna kind of come back down, and we're gonna do some more basic stuff. So we got that. They have examples in the book too. How do you read something like this? Have you guys all filled out a check? It's funny, I just thought of it.
No.
Bring a check for next time. I want you to write some examples and then give it to me. Sorry. Leave the things blank. No.
Yeah, just pass around your checkbook and we'll hold right one up.
Oh, thank you.
Oh, I can quickly learn how to write a check then.
Is that your name?
I'm a teacher. That'll run out quick.
Run out quick.
You guys have written checks. So how do you do it? Don't you put like, if it was 180.11, what do you write in the next line? 100? No, you don't. You write 180 and 1100s, correct? Okay, so how do I say this? How do I read this number? Don't say and. The only and is where the decimal is. 123 and 456 thousandths. I like this. So this would be 100. Oh God. 23.
Is this gonna be on the
You gave
test?
yourself such a long number.
I know. 457, 56 thousandths. I gave up on some letters.
Are we gonna have to write out the word, like the numbers and words?
Yes, that'll be part of it.
No, on the test. We don't love
Oh.
us.
Oh, you guys all okay? We've all seen the kind of thing. That's you got to be very specific when you're doing this because the and is the decimal placement. Is really what it is, and that's why the checks have a very kind of like formulaic way. The bank is going to cash the damn thing if you put the and in the wrong place. They don't give it. Bless you. Okay, but the and should be where the decimal is. So that's one little tiny thing. So let me show you one way to visually represent a decimal. So if I only consider going out to the hundreds place, yeah. So here's a base 10 flat. How many little units are in there? 100, 10 by 10, yes? So isn't each one of these, how much of the overall shape is each piece of this?
1%.
One, yeah, sure, but say it 100, so 0.01. So how much is this? Well, how many of these fit in there? 10. So how much is this one by itself? 1/10.
10.
You with me? So this whole thing would be 1. This is 1/10 of that 1. This would be 100th. Which is what? Is how much of this shape is this? Whatever this shape is, this would be how much of that shape? 1/10. But isn't this a tenth already?
Yeah.
So what's 1/10 of 1/10? 100th, which is another visual of why you multiply fractions. Okay. So if I wanted to represent 0.12, and if I broke this down into expanded form, this would be 1/100th and not hundredth,
Yeah, that's what I say.
1/10 and 200ths. That's the human proclivity to just agree, just happen. So 1/10 and 200ths. I like it. So if I want to represent that, it'd be 1/10 and 200ths. Y'all with me? Unfortunately, like I said, we don't really have the most parts to this thing, but oh. So if I wanted to add 0.12 plus 0.24, so there's 0.12. Here's 0.24. So this feels a lot like the stuff we did earlier this semester. It's exactly the same idea. I can just look at Jeff just effortlessly doing this while the furniture moving class does this thing. So what do I get?
3 times.
3, 6, 11. Or like you said, I'll get 3/10, 600ths. I like it. Now, real quick, this right here is a great little example of what's going on here. I can't add these two, correct? Not the way they are. Not as fractions, anyway. Why not?
They don't have common denominators.
Yeah, they don't have common denominators. So how do I make common denominators? Yeah, and then it becomes 12 over 100, which is our nice 0.12. I love it, right? That's the idea of I can keep adding as many zeros after decimal places if I want to, because it will reduce back to the same thing it was before. Okay. Make sure I did. Oh yeah, we did all that. We did all that. We did all that. Okay. We did all that. Oh, good. All right.
Does the dean know about this furniture moving class?
Oh, I mean, they just have to do it. Yeah. There's no great way around it.
Is it
We should get some of those little, what do you call it? You know, the little, what you put on the bottom furniture so it doesn't scrape up your.
Oh, yeah.
Oh, like the rubber stuff.
The felt, whatever it is, you
Either
know.
that or everybody should just start pounding on their walls when they start moving in. Or no, what?
Well, then it would be furniture moving in.
We can
No,
all
when they're
jam on the
stopped.
Ceiling with them.
We could make music out of it. I don't know.
Yeah, let's jam with our birds start on the ceiling.
I'm pretty sure they're
That
both
happened
wall
before,
wise.
it's exciting. All right.
At your home?
Yeah, yeah. We're a little something. What's fun? We weren't that long. Anyway. Let's see, a couple more things. Sure, okay. So what if I needed to add 0.5 plus 0.28? What do you think the most common mistake would be for a student about to do this?
Just add it.
Add the 5 to the 8.
Yeah, they would just line it up like this, and they would get 0.33. Hopefully they would know about carrying the 1. Now, of course, is that right? No. Okay. So, we're going to talk about, of course, we all should know what has to happen, but now it should make a little more sense why. 0.5 is what is a fraction?
It'd be 1 over 2.
Well, directly it would be 5/10. It is a half, you're right, because it reduces, but 5/10 because of where it is. 0.28 is 2/10 plus 8/100. So of course I can't add the 5 and the 8 because they are not like terms. Right? Okay. So of course the 5 and the 2 should go together. Now of course we all know the best way to show the student this. What do I do if I had 0.28 plus 0.5? If I want to line it up, I make them put a 0 there, so then it makes more sense. And of course we have to explain why 0 there makes sense. What is 0.50 officially? 50 over 100, which reduces to 5/10, which explains why that's the same number. Okay. A lot of this stuff, though, you gotta be really careful. We take it so for granted because we've done it forever. but you're going to be dealing with little people that are brand new to everything. So you got to be really careful on yourself about not taking things for granted as to how things work. Okay. Oh, all right. So let's talk about this. How do I tell which is bigger? We'll do more with this here later about adding, subtracting. I just want to say that. 0.17 versus 0.3. Same kind of idea here, right? How can I do it visually? Tell which one's bigger.
Using your little blocks.
Yeah, my little blocks. So if I want to represent 1/7, it'd be 1/10 and 7. Oh, Jeebus.
Big
There we go.
log over.
Pick the wrong day to stop Smith and glue. Now that's 1/7. And if I also represent 0.3, which is 3/10, now for a student it's crazy simple to see, well that's a lot more. Whereas at first they could think, of course you all know, a student's gonna see 3 and 17. And then 3 is less than 17, you crazy person, what the hell are you talking about? Hopefully not a little, 3 is less than 17. So visually, that's one way to do it. It's just to represent each one of those using base 10 pieces. What's a way to do it? Well, how about using fractions? That would be not too bad, right? What's 0.17? 100, and 0.3 is 3/10, which becomes 30 over 100. Right? Now that of course is an intermediate step, because what we really should do, the ultimate thing to do, would be just to make it 0.17 versus 0.30. Oh, and this explains why that makes sense. Now it's 17 versus 30, now it makes sense. And again, we all know this stuff, but it's going to be in terms of how to build it for somebody who doesn't really know this yet. Okay. How about, let me ask you this. How would you do this problem here? You had to do this in your head. In your head. What idea do you think I'm wanting you to use? In fact, let's make it like this.
No, I was doing something different.
So if I said 4 plus 7 plus 6, what would you guys do first? 4 and 6, right? Because they fill each other in. Well, what two numbers fill each other in?
2.8 and 1.
Yeah. What's 2.8 plus 0.2?
That's 3.
3 plus 1 is 4. This is 4 plus 5.6, 9.6. So what two things did I just use? I used two properties and I used one idea. What's the two properties I used?
Or this, no.
Associativity and commutativity. What's the one idea I just used? What kind of numbers?
Compatible. Number.
Compatible. Get along. Aw. You guys don't with me? So just because they're now decimals doesn't mean those old ideas of compatible numbers and compensation and all that kind of stuff, it's still all there. What about this? Let's see if you guys remember this kind of thing. Sure, that's freaky.
I got my calculator.
Not well, I mean, sure. That's like, you know, PEMDAS is always there. PEMDAS surrounds us. No, it's not before surround. What property could I use considering both multiplication pieces have a 0.3 in them?
Distribution.
Good. In reverse, right? And what's really cool about these two things? If I take a 0.3 out, I'm left with 61 plus. And what is 61 plus 39? You can even use compensation here, right? Take one, give it to him. 90 positive variable. So 60 plus 40, 100. That's crazy. What's 0.3 times 100? Move it once, move it twice. Yes, I love it. Multiplying by any multiple of 10 should be easy as hell. You just gotta move the decimal the right number of places, yes? Okay. I like it. What about this? Does it ever end? No. You know better than that.
It's math.
You have to remind yourself, by the way, I know some of you guys have had bad experiences, you've had bad teachers, you've had whatever has happened to you about mathematics. Your students are fresh slates. They're gonna love the shit out of it. They're gonna wanna do whatever, especially because there's all kind of stuff they can play with. They wanna please you, they wanna show off what they know, right? They're gonna be so ready to just, whatever the hell, just absorb the hell out of it. Does anyone remember what I could do here besides use my calculator?
411 minus 194.
You sort of could. You sort of could do that because they have the same place values, but I still have sort of the same issue. I want to be able to do this in my head.
Yeah,
Huh? Oh.
Make 1.94 into 2.
Yeah, if I increase this by 0.06, and I increase that by 0.06. Remember that's equal additions? Remember that idea? So then I can make this 4.17 minus 2, and that's easy. 2.17. Great. Done. So that's just a generally good thing to know. Not even just because you're going to be future teachers, but just every human should know that shit. Well, basically, almost everything else anyway. You guys kind of with me? That doesn't go away just because they're decimals. I can still use all the same stuff we used before. Alright. So last thing for today. I think I've spoiled you guys. I'll let you guys start rolling. What are we doing still here? So real quick, you guys already know most of these things, but 0.5 of course is a half. What's 0.25?
1 over 4.
What's 0.125? So real quick, 0.5 is a half. 0.25 is a half of that. A half of a half is a fourth. 0.125 is exactly 1/2 of 0.250. What's 1/2 of 1/4? 1/8. Y'all kind of with me? So what is 0.375? Here's something kind of cool. You ready? No? Oh, I see what you're doing. See, I didn't go that way, did I? Yeah. Real quick, do you guys see how this plus this equals that? You guys see how this plus this equals that? No?
3/8.
Yeah? Can everybody see how this plus this equals this? Okay. Therefore, this plus this must be this. So what's 1/4 plus 1/8? It's 2/8 plus 1/8.
3/8.
3/8. I love it. So what's that mean, Jeff? What can I do with that, Jeff? Well, if I had to do 0.125 times 848.
Take an 8 out of 848.
I know the equivalent fraction. This makes this so much easier. 0.125 is 1/8. Does 8 go into 848? 8 goes into 8
Yeah.
once. 8 goes into 48.
6 times.
6. You guys all with me? You okay? Yeah. Alright. So you guys always look like you're having stomach trouble. I'm used to it. I'm a math guy. I make people a little sick to the stomach. So I know some of the stuff you came in knowing. Did anyone ever see that thing we did with 0.33 ever before, the equals x and so forth?
No?
So every single repeating fraction you can do that with. It's kind of nifty. Alright, so just to remind you guys, we have another quiz, because we like them so much. We have another quiz on Thursday, 6-2, 6-3. And then a week after that, we're gonna have the test. So Thursday I'll have the practice test. Next Tuesday will be review day. Alright, so next time we'll watch some videos, we'll do some group work, we'll do some manipulative stuff, and we'll finish up chapter 7 is my hope. We'll see what happens. Okay.
For the final,